Definitions from his book Elements, Euclid went on to explain some axioms that would help in understanding geometry better. What are axioms, you may ask? The general meaning of an axiom is a statement that is universally true and needs no proof. For example, we all know that most humans have one brain. We just know it's true and must be accepted. Similarly, Euclid assumed that some properties were true and did not have to be proved. He called these truths as axioms. These axioms are not restricted to geometry and can be applicable throughout mathematics. They will help us to prove and understand complex geometry in the upcoming lessons. In this lesson, we will study some of his axioms. The first axiom is, things which are equal to the same thing are equal to one another. What does this mean? Let's understand with an example. Suppose Bob and Rob go to a store and both of them have 5 rupees. Bob buys a pen for 5 rupees and for the same price, Rob buys 2 candies. This means that the cost of one pen is equal to the cost of 2 candies. So if later Rob wants to trade his candies for Bob's pen, he would have to give 2 candies to Bob. This means the value of one pen is equal to the value of 2 candies. In mathematical sense, if a quantity A is equal to B and B is equal to C, then A is equal to C. The second axiom states that if equals are added to equals, then wholes are equals. To understand this axiom in a simpler way, imagine if for 5 rupees you get 2 candies and for 7 rupees you get 1 pen. So if you add them together, you will see that for a total of 12 rupees, you will get 2 candies and 1 pen. In the mathematical sense, let's say a quantity A is equal to C and quantity B is equal to D. Then A plus B will be equal to C plus D. The third axiom says that if equals are subtracted from equals, then the remainders are equal. Similar to the second axiom, if a quantity A is equal to C and quantity B is equal to D, then A minus B will be equal to C minus D. We will explain the remaining 4 axioms in the next part of the video. Around 300 BCE, the Greek mathematician Euclid combined all the knowledge of geometry known at that time in a set of 13 books called Elements. One interesting thing Euclid did was that he set out to prove that the geometrical relations known at that time follows logically from some simple things we know intuitively to be true. Euclid showed that the knowledge of geometry can be proven by just assuming some things to be true. These 5 true statements form the base of all modern geometry. He called these true statements or facts as postulates. You'd be wondering what the difference between axioms and postulates is. Well, in geometry, they are essentially interchangeable. The general meaning of postulate is a true statement. But in the case of Euclid, a postulate is a true statement, or rather a fact, that's applicable in geometry only. So in this lesson, let's take a look at the 5 important postulates that Euclid devised which helped him prove more theorems. Let's have a look at what the first postulate says. It states that a straight line may be drawn from any one point to any other point. To understand this, suppose we have 2 points A and B separated by a distance. Now, if we want to join them, we see that we can draw only one straight line that will connect the both of them. We can take the help of Euclid's axiom that states, given 2 distinct points, there is a unique line passing through them. So a line from A joining B is AB. Similarly, the line joining A from B is also AB. The second postulate states that a terminated line can be produced indefinitely. By terminated line, we understand that it's a line segment. This postulate means that if we have a line segment AB, we can extend both its ends endlessly. What about the next postulate? The third postulate says that a circle can be drawn with any center and any radius. This postulate is self-explanatory, but for our understanding, let's assume a line segment AB. Keep point A fixed and move point B around point A. We will see that it will make a circle, and the length of the line segment AB will be the radius of the circle. Likewise, we can draw a circle from any point and with any radius. The fourth postulate says that all right angles are equal to one another. Look at the square and a rectangle. We see that all the interior angles of the rectangle and the square are right angles. Therefore, an angle from a square will be equal to an angle from a rectangle. So, these are the Euclid's first 4 postulates that will help us having a better understanding of geometry. In the next lesson,